Y'all, so like I said, this is 6.1 support, and this deals with domain of radicals. So this is finding the domain of a radical expression. And y'all remember when I talk about radicals, we're talking about square roots in this section, okay? So I'm gonna pull my chat up. Um, let me find my chat. All right, y'all. So my question is, what's the smallest number can you actually take the square root of and get a real number? Oh, Charles, I can actually go smaller than 4. I can go smaller than 2. So 1's getting close. I can take the square root of 1, and that's 1. But the smallest number, what do you got, Rebecca, is 0 for sure. Remember, square root of 0 is 0. Now, when you try to take square roots of negative numbers, you get imaginary answers. So y'all recall this. If you try to take the square root of a negative 4, we're not able to do that because like signs are always positive. So what they said was, we're going to let square root of 1, negative 1 equal I. So then what they did to this square root of negative 4, they separated that in factors of 4 and negative 1. That way now we can actually take the square root of 4 now, right? Square root of 4 would give me 2. But now I cannot take the square root of negative 1, but we're going to replace that with the I so that we get 2I. So square roots of negative numbers end up as imaginary, okay? So that's why under this radical, it cannot be negative when I take that square root, okay? So when we look at our domain, 0 is the smallest number that can be under here when you take the square root, okay? So let's put our steps to finding the domain. Now, since the smallest number this can be is 0, what I'm going to do is I'm going to set the radicand equal or greater than, equal or greater than 0. Now, y'all, the radicand is the A under here. Whatever's under that radical is called the radicand, okay? So we're going to set it equal or greater than 0. Then we're going to solve it for the variable. Now here's the thing. If there's stuff outside that radical, I don't care. It's got to be under the radical, okay, y'all? So once we solve for the variable, in this section, we're going to learn a new way to write our answers. Instead of using set builder notation, we're going to use interval notation. So I'm going to write my answer in interval notation. So I'm going to explain interval notation real quick before we do our first problem, okay? So with interval notation, we don't write all these words out like x, such that x is a real number and all that. We use parentheses. So in interval notation, all real numbers is represented. Well, let me ask y'all this. If I get negative and I keep going in a negative direction, what do I say I'm headed off towards if I just keep going and going and going in the negative side?
Infinity, negative infinity.
Negative infinity. There you go. So when we write all real numbers in interval notation, our left side is going to be infinity, because that's the farthest I can go to the negative side. Now, how about to the positive side? I keep going positive and more positive and more positive.
Positive infinity.
Positive infinity. There you go. So negative infinity to infinity represents all real numbers on this, y'all. Okay? So what do I do if I want to pick a number out? Now, if y'all remember, let me ask y'all this. Do y'all remember stuff about if it's greater than or equal or less than or equal? You use brackets around the numbers. And if it's just less than or greater than, you use parentheses around the number, okay? So if it actually equals that number, we're going to use brackets. If it doesn't use the equals, we'll use parentheses, okay? So all real numbers, like I said, negative infinity to infinity. Now, y'all, the reason infinity has to use these curvy parentheses is there's no ending point. It keeps going and going and going, so that's why we use curves on it every time, okay? Now, to exclude a number, from the domain, we use the union. So in math, the union is that union looking, it looks like a U. Oh, y'all, hang on just a second. I got to see who just came in here. All righty. This means and. Okay. So watch how I'm going to exclude a number. So to exclude any number A, so A can be any number. To exclude any number A, we would write, well, remember, we're starting at negative infinity on the left side. We go up to the number we're excluding, and we put parentheses around it, and then the union, and then parentheses and the number again. Since these parentheses are curved, that means it does not contain A in the domain, okay? It's like we're excluding it since we're using the curves. So you go from negative infinity up to the number, and then you start with the number and you head towards positive infinity. So this move right here, using that union around these numbers here, is how you kick it out a number from your domain, okay? So for example, find the domain of f of x equals 1 over x minus 2. Y'all, what's the only number x cannot equal down here?
Positive 2.
Positive 2. So we know x cannot equal positive 2. So to kick that out of my domain, I would write negative infinity to positive 2, union around that positive 2, and head off towards positive infinity. So in the future, when we do the ones with the fractions, that's how we're going to kick out our numbers, okay? But y'all, we're using radicals today, okay? And radicals are greater than or equal to 0. So since they're going to be greater than or equal, we're going to use the brackets for those ones, okay? All right, let me let one in. All right, also, let me turn my page. Okay. Finding the domain of the radical function now. I gave y'all the steps a while ago. So for this first one, we're doing f of x equals square root of 100 minus x. Now this will bring back a few memories also. So what I'm worried about is what's up under this radical here. That 100 minus x, so remember we're going to set 100 minus x has to be greater than or equal to 0. Now we're going to solve that for x. Y'all, to solve this for x, I'm going to subtract 100 from both sides and move that over. So these hundreds over here are going to kick out. So I'm going to be left with that negative x greater than or equal, and 0 minus 100 gives me a negative 100. Now, here's a question for y'all. If I divide by -1 to make that x positive, since I'm dealing with an inequality, if you divide an inequality by a negative number, y'all, there you go, Carlith. It's got to change it and reverse it, okay? We got to flip that inequality. So I'm going to divide by -1. Since I'm dividing by -1, this greater than or equal is going to become a less than or equal. So reverse the inequality. Since dividing by a negative number. Now we didn't do it when we subtracted this 100. It don't matter if we're subtracting 100. It matters when we divide this thing, okay? So now that negative divided by negative makes this x is less than or equal, and then that's going to make that a positive 100. So now look here. The largest number this can be is 100. So on the right side, my largest number is going to be 100, and it's going to have a bracket. Because of the equals. So y'all see the difference? On the fractions, it couldn't equal that number, so we use parentheses. This can actually use the 100 here. And then, oh, Charles, look at you go. And since it's less than, that means on the left side, where am I coming in from? If I get smaller and smaller and smaller and I'm more negative, I'm coming in from negative infinity. And that always uses a curvy parenthesis. Oh, good job, Charles. So if it's less than, you're coming in from negative infinity. If it's greater than, you're going to be headed off towards positive infinity, okay? All right, y'all, let me see what y'all do here. We're going to find the domain again. F of x equals square root x minus 3. All right, so x minus 3 is up under that radical, so I'm going to set x minus 3 has to be greater than or equal to 0. So I pretty much just got one move on this one. I'm just going to move that negative 3 by adding 3 to both sides. So y'all bring down my x. The 3's cancel on the left side, and that's going to be greater than or equal to a positive 3. Y'all notice this. I did not flip that because I did not divide by a negative number. So y'all, what y'all think this domain is going to be? Because on this one, 3 is the smallest number it can be. So 3 to infinity, good job. So since 3 is the smallest number, it goes first. And then anything greater than, like y'all said, is headed off towards positive infinity. Did y'all notice this? Y'all notice this. You see how this one's pointing left? When it points left, you're coming in from negative infinity. When it points right, you're headed towards positive infinity. That little inequality sort of points the way of the infinities, okay? All right, y'all, so that was good. Let's try this one. So domain of this one, okay? Eight minus x. Oh, I bet I'm about to get all of y'all, ain't I? All right, somebody, come on. What's the domain of eight
It's
minus
it's
x?
it's just negative infinity to infinity because it's
Oh
just a
my God, good job. I don't see a fraction there, do y'all? I don't see a radical there, do y'all? So remember, the only things we're worried about are fractions and radicals. This sort of goes back to the stuff y'all did back in, what was it, 2.3? Where y'all kept putting all real numbers, except for one or two that had a fraction on it actually. So yeah, y'all, this is just a trick question, but there's no radicals and fractions. So that's just going to be negative infinity to a positive infinity. But y'all, that's the support. Doing those three problems, okay? And getting used to this interval notation. All right, also, here's the thing. 6.1 college algebra has one question doing domain, and then it's just picking out graphs on the rest of it, okay? So, now the thing about this domain is they're still writing this domain in set builder notation, okay? where you have the x such that x is whatever, okay? So 6.1, radical functions. Oh, y'all, so my very first one says, determine the domain. So you got one domain problem, and then, like I said, about 4 or 5 of them going to be looking at pictures. So f of x equals the square root 2x plus 3. And then they'll have an A, B, C, D with the answers on it. All right, all this is under the radical, so I'm going to take that and set 2x plus 3 greater than or equal to 0. So remember, radicals, we always set greater than or equal to 0. Fractions, we set them equal to 0 because we were kicking them numbers out all the way, okay? All right, y'all, so 2 moves on this. Let's see, we're going to subtract that 3 over. So my 2x, that cancels, is greater than or equal to negative 3. Okay, I'm going to divide, and I'm going to get, what you got there, Carlethia? Negative 3 halves, looks good. So that gives me my x greater than or equal to negative 3 halves. And we didn't flip it because we didn't divide by negative over here, okay? Now in MATLAB for this problem, our answer will be in set builder notation, and it'll be x such that, and then you basically put in the answer, x is greater than or equal to negative 3 halves. Okay, so the support uses the support uses the interval notation. College algebra on this problem use set builder notation. But just watch out, they got a greater than or equals, a less than or equals, a not equals, and then all real numbers, okay? All right, y'all, then we're going to get into graphing. So I'm going to graph 1 or 2 by hand. All you're going to do is graph these and then look at the pictures in MATLAB. I'm going to graph it by hand first, and then I'll do it on the calculator because either way works. So I got f of x equals 3 square root of x. So y'all, I'm going to do it by hand real quick. I'll go out about 10, I guess. Alrighty. I am very picky when I pick these x's. Um, so Charles, what's going to happen when I pick my x's? I'm going to be focused on this radical. But what's going to happen, whatever I take the square root of, is going to multiply by 3 to give me my y value. Okay? Oh, Carlethia. Carlethia, 0, 1, 4. Perfect. We're picking numbers that we can take square roots of. If you put a number in there, well, like 2. 2 is a never-ending decimal. It don't have a perfect square root. 3 does not have a perfect square root. It's a never-ending decimal. I want numbers under this that I can take square roots of. So if I put a 0 in here, square root of 0 is 0. And 0 times 3 gives me a 0. All right, what about a 1? If I put a 1 in here, square root of 1 is 1. 1 times 3 is 3. So I can almost follow Carlithi on that chat over there. And then if I put a 4 in here, square root of 4 is 2. And 2 times 3 will give us 6. Good job, y'all. So just let me just see what would be my next number I'd probably pick if I was to pick one more. Carlitha, good job. It would definitely be a 9. Because 9 has a square root of 3. And then 3 times 3 would make that a 9. So you want perfect squares under this radical on this one, okay? Now y'all remember, the basic graph sort of went uphill to the right. Well, this is still going to look like that, but this 3 being multiplied is going to make it a little taller. So here was 0, 0. Right 1 up 3. Over to 4, 6. And then over here at 9, 9. So it sort of just goes up to the right there, okay? So I can do that on my calculator. I'm going to share that calculator, y'all. And I can use my y equals on it. All right, so go to y equals. I had 3, so 3. Square root is the second blue button. And then come down to the x squared button. It's got that little blue radical above it. So when I hit the blue button, I get the radical. And then I'm going to put my x under there. So there's my 3 square root of x. Now let me show you the table. So I'm going to hit second graph. So there's those negative numbers. There's those errors I'm getting because of that imaginary stuff. So 0 gave me 0. 1 gave me 3. But y'all look at that. 2 gave me 4 point. And that ain't even the whole decimal. Look, this thing's 4.2426. I don't even know where to begin to graph that. 3 did the same thing. But when y'all gave me that 4, I got a nice 6. And then down here at 9, I got a 9. So find perfect squares under those radicals, okay? All right, y'all, let's hit graph and see the graph. It should look like what we had. All right, y'all, question on that? All right, so let me do another one here. So Curly, what do you mean by how do I make my graph smaller? Are you talking about in MATLAB?
Yeah, no, I'm talking about on your calculator, how your calculator look. My calculator doesn't show like the full right hand box, upper right box. It just like shows partial. It only goes to like 4.
On your graph here?
Mm-hmm.
Okay, so do this. Hit the zoom button in the middle up there. Hit zoom, and then go down to number 6 and hit enter. That'll put you back on a 10 by 10 graph.
Thank you.
Okay, you good?
Yes.
Okay. All right, y'all, so let me see on this one. Let's try this one here. So I want a graph. F of x equals a square root x minus 9. Now let me ask y'all this. In 7.2 last week, if I subtracted 9 from the x up under that radical, which way did it actually move this graph? So remember, I'm attacking the x under, it's sort of like it's in parentheses. So yeah, it'd go right. When you subtract, it went right. When you added, it went left. So when we're done, this thing better go left, okay? I mean right. It better go right. All right, let's see. Let me see what kind of x's we'd pick on this one. I probably wouldn't use a 0 because 0 minus 9 would make that a negative 9. So what's the smallest number I would probably use for that x? Would be whatever number gave me a 0 under there. So it'd be a 9. Good job, y'all. Brandon, that's a good one. 9 works. Because y'all, 9 minus 9 is 0. Square root of 0 is 0. All right, what's my next one? I need to get a 10. That'll give me a 1 under there. 10 minus 9 is 1. Square root of 1 is 1. Oh, how about one more? So, Carlithia, good job. 13, that'll work. Because 13 minus 9 gives me 4. Square root of 4 is a 2. So y'all getting the idea? You're picking x's that'll give you a perfect square under that radical, okay? All right, y'all. So I'm going to go out a little bit further this time. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All righty. So 9, 0. We all look at that. All the way over here at 9, 0. So it looks like Charles was right. It moved me right pretty good, didn't it? And then 10, 1 would be right here. And then I had 13, 2 about right here. So if you notice what it did, it shifted my graph to the right 9 units, okay? So you can sort of almost do the stuff we did in 7-2 to sort of figure out what's happening to the graphs, okay? All right, y'all, so that's pretty much what you're doing in 6-1. You had one domain problem, and then the rest were just doing graphs and picking out 4 pictures, okay? And usually what they do on the pictures is they'll move one up, one down, one left, and one right.
And Mr. Rathcline.
Yeah, I hear you.
So for y, what are we trying to make sure that that is capable of being again?
What I'm trying to get under this radical under here, this x minus 9, I want that to equal a perfect square under there. So I'm in my perfect squares. So my perfect squares are numbers like 0, 1, 4, 9, 16, 25. Numbers you can take square roots of. So when I was looking under here and I was like, well, my smallest perfect square is 0. So what could I make that x so that this equals 0 under here? So I picked a 9 first because 9 minus 9 equaled that 0. So then we said, well, what would make that equal 1 under there? Well, if I put a 10 in for x, 10 minus 9 gave me 1. And the square root of 1 was 1. So next I wanted it to equal 4 under there. So Carlithia said, well, put a 13 in there because 13 minus 9 gives me 4. And the square root of 4 was 2. So you want this under that radical to always equal a perfect square so that you can take the square root of it, okay?
Gotcha. Thank you.
Okay. All right, y'all. So that was what 6-1 college algebra. Next, 6-8. Now 6-8 is going to be a little longer. We're going to do about half of it tonight, and then I'll finish the other half up when we come back Thursday. So this deals with increasing decreasing, and piecewise functions. So y'all, I'm going to start out with the piecewise functions. So a piecewise function, we're going to have several equations, and the domain will determine which equation I use when I want to evaluate it, okay? So a set of equations in which the domain determines which equation we use to evaluate a given x value. So I'm going to play with y'all for a second. Have y'all ever used the piecewise function in the real world? Oh, Cardiffy, I bet y'all have. All right, let me ask y'all this. Do any of y'all work by the hour? So let me ask you this. You get paid so much money an hour, right? Now, when you do overtime, do you get time and a half pay? So right there, so y'all ain't that two different equations to figure out your pay based on how many hours you work? So if your domain is up to 40 hours, you got straight up regular pay times how many hours you worked. But if you went over 40 hours, your pay had time and a half for anything over that 40 hours, right? So, y'all, that's a real world sort of situation where you deal with piecewise functions, okay? So, let's say this person makes $20 an hour. Their pay, now T is my variable because that stands for time. So instead of X's in the real world, a lot of time it'll be T for time, okay? So up to 40 hours, I make $20 times my hours. And that'll be for any T less than or equal to 40. Now, if I make overtime, let's see, 40 hours at 20 would be 800 a week plus time and a half on 20 is $30 at my T minus 40. That's going to be for any T that is greater than 40 hours. So y'all, when I did 40 hours is $800. And then say if this was 45 hours you worked, 45 minus 40 would give you 5 hours at $30. Okay? So this will start out asking you questions like this. Which equation would I use to find P of 37? So I only got to work 37 hours. Would I use my first equation or my second equation? Yeah, y'all would be the first one. Good job. Because remember, 37 is less than 40, so I got to use the first equation, and that would be the 20t. So if I wanted to know actually how much I would make, I'd put the 37 in for the t, multiply that out, and be done, okay? All right, so let's do one like MathLab has set up. So they're given f of x here. Now I got three equations here, okay? It equals x minus 5 for x less than negative 4. It's going to equal 8 times x for negative 4 less than or equal to x less than 1. And it's going to equal x squared for any x that is greater than or equal to 1. All right, y'all, so let me explain my domains here. If my x is less than negative 4, I'll use the first equation. Now, it can't equal negative 4. It's got to be less than negative 4. Numbers like negative 5, negative 6, negative 7, negative 8. All those numbers that are less than negative 4, I'll use the first equation. This one tells me if my x is equal to negative 4 or less than 1, if it's in between negative 4 but less than 1, I'll use this second equation. If it equals 1 or anything greater than 1, I will use the third equation, okay? So what I want to know, which equation would we use to find f of negative 5? So y'all, my first, second, or third one for that one. What y'all got, Angela? Oh, y'all good. Y'all all got the first one. Good job, because negative 5 is less than negative 4. So we would use the x minus 5. So how about this? Which equation would we use to find f of 1? First, second, or third?
Would it be the x squared? Because it's equal.
Yeah, exactly. Because that 1 equals 1, right?
Mhm.
So this one says if your x equals 1 or is greater, you better use the x squared one. Good job. Okay, so y'all, I'm getting a few that are saying the second one, but see, the second one says if your x is less than 1. So this one goes up to 0, all the way up to maybe 0.999, but it cannot equal 1. If it equals 1, you got to go with this third one, okay? All right, y'all, so this section will start out dealing with piecewise functions. Then we're going to get into the increasing and decreasing intervals. So we're going to be looking at increasing intervals. Then we'll look at decreasing and constant. Now, when I talk about increasing intervals, decreasing intervals, and constant intervals, I'm worried about the x values. So this is the x values for which the graph is going uphill from left to right. All right, y'all, we always read a graph left to right. We never go right to left on them, okay? It's always left to right. So it's going to be going uphill from left to right. And notice, it's the x values. What x value does it start at going uphill? And then what x value does it end at going uphill, okay? Decreasing intervals. Those are going to be the x values for which the graph is going downhill. From left to right. Okay, so this one's sort of going to go up. This one's sort of going to go down. Then we got constant interval. And I'll tell you this, increasing intervals have a positive slope that goes uphill. Decreasing has a negative slope. Well, y'all, constant is the x values for which the graph is a horizontal line. From left to right. So it's sort of going to be a zero slope. It's just going to be a straight line going across. So your three intervals, increasing, decreasing, and constant. Now to write my intervals, I'm going to put them in interval notation using the parentheses, okay? So y'all, I'm going to try to draw an interval here for us to play with real quick. And then we'll do the rest of them on Math Lab. So let me go out about 7 or so, okay? All right, so let me see how I want to draw this. So over here at -3, 2, I'm going to put a point. And then at 1, 2, +3, 2, I'm going to put a point. It's going to go straight across right there. And then this side is going to go up. And this side will come up. Okay, so this one's really straight right here, y'all. So it looks a little crooked, but that's a straight line going across there, okay? So I'm going to show you how to do the intervals of increasing, decreasing, and constant. Now, y'all, where I get people at on this problem is they want to write y values on it. I do not want one single y value because this says it's the x values that this is happening, okay? So increasing, going left to right, the only one going uphill is this one right here. This part's going uphill, which means it's increasing. So I'm going to put my curvy parenthesis. My question is, where does it start increasing at? 3, good job. So 3 right here on the x-axis. Now, here's my question. As these x's are headed off toward the right, what are they headed off towards?
Positive infinity.
Positive infinity. So increasing from 3 to positive infinity. All right. Decreasing is this side going downhill left to right. This is going downhill. Where does this section start going downhill?
Oh,
I'll keep
negative,
it. You're going, say that again.
negative infinity,
Negative infinity. Y'all, it's coming in from negative infinity out here. And it's decreasing until it hits what?
negative, oh,
Oh, you're good. Say it.
-3.
-3. Right here, y'all, right there on that x-axis, that point is at -3. So constant, y'all, is this little section right here in the middle. Straight line, left to right, going across. Carnitha, you're quick. -3 to 3. There you go. So these will all hook up eventually. Negative infinity to -3, it was going downhill. -3 to 3, it went straight across. And then from 3 to infinity, it went uphill. All right, y'all, so hang on 1 second. I'm going to pull MathLab up, and we're going to play with what they got on there, okay? All right, so y'all hang on. I got to reset it. I guess I went out of time on it. All right, I think I'm good now. So y'all, let me share this screen. All right, so these are like 4, 5, and 6, I think, have this going on. So I'm gonna make this graph bigger. And this was sort of like the one I just did. So first, y'all, are y'all seeing my graph? For number 4, are y'all seeing that?
Yes.
Okay. So all right, so y'all listen. A, B, C, or D. The function is increasing on what interval? A is perfect. Now, y'all, D has the right numbers, but we don't use those brackets. Because that point where 2 is, it can't be both constant and increasing. So we always use the curvy parentheses. So that would definitely be A. And then you check your answer. All right, y'all. A, B, C, D. Where is it constant? So Carlithian, I think you are right. It's A again, right? -2 to 2. So it looks like it's -2 to 2 on the x-axis. So I'd pick A for that. All right, y'all, look what's left. Decreasing. That's that left side over here. So A, B, C, or D on the decreasing. So negative infinity, let's see, is that good job? That looks like negative infinity to -2. So we're going to go with C on that one. Okay. So y'all, that's the trick on that one. That is not too bad. But y'all watch what I got coming up. So let me make this one big. So y'all realize this has 2 places going uphill. The second line slanted uphill to the right, and then the 4th line over here is going uphill. The very first one down here is constant, and then that third one is going to decrease. So let's work on this first one, this long line going uphill to the right. What interval is that going uphill? So we want to find this point right here on the x-axis. So that one looks like I'm at what? -1, -2, -3, -4, -5. Good job. That looks like -5 to 2. And there's only one right answer that's got a -5 to 2 for that part. And then it's including this second part. So I guess that means this second part is what? So we got 1, 2, 3, 4, 5. Looks like 6 is where that was starting at, right? And then it's going 7, 8. So 6 to 8. What do you got, Rebecca? 8, that's what I'm going to pick too. So it's got to have both of them, okay? So it's either got to be A or D for sure. B and C don't got but one interval, okay? So you got both the intervals. You click your answer. Now this one we actually got them right. What interval is this third section decreasing? So y'all tell me what to write on the blanks on this thing. So this first dot, if I came straight down, what does that look like? That looks like 1, 2, 3, I think. Good job. And then let's see. So that was 3. Then we got 4, 5, 6. So 6. Actually, it's not negative, Caleb. It'd actually be a positive 6 over there. Because you're doing x-axis, okay? So you're going to the right. Although it's below the x-axis, the y value would be negative, but that x value is still going to be positive, okay? All right, y'all, then we'll check that. Constant, this little bitty section down here. Where does it start
And
going?
I have a question.
Okay.
I'm confused on the decreasing. What are we counting?
Oh, I'm counting these x's down here. So watch this. I'm going right. I'm starting at the center here. I'm going right 1, right 2, right 3. At 3 on the x-axis, if you go straight up, that's where that line is starting to go downhill at. Now, I'm going to go right more. So here's 4, 5, 6. At 6 on the x-axis, if I go straight down, I'm at my point. So between 3 and 6 on the x-axis is where that was going downhill. I don't care about the y value way up there being 8 and the other y value being a negative whatever, okay? I'm just looking at these x's down here. So what I do is I start with the first point where it starts going downhill, and I just come straight down to the x-axis and see where that point is, okay? Now over here, the point where it stops, I'm going to go straight up to the x-axis and see what that point is on the x. And that was where the 6 was.
Okay, that makes more sense. I was
Mhm.
trying to count the Y values and I was getting really confused.
No, no, no. Do not care about the y. I don't care how high it increased or how low it decreases or whatever. I just want to know on what x values did it happen. So let me see if you got this. Look down here at this little constant one down here on the left side bottom. Where does this one start being constant and where does it end? So this first dark point, I'm going to go straight up to the x-axis. And that starts at -8. So Carletha got that one. -8 it started at. Now, it's constant until it gets to that little hollow dot. So what's that hollow dot? Well, if I go straight up, that looks like what? -5. There you go. So Ella, on these, you are definitely only worried about the X's down there, okay? All right, y'all. So I'm gonna do one more now. This one's the fun one. Now this one says, find the intervals on which it's increasing. Type your answer in interval notation and use a comma to separate your answers. Well, y'all look here. The first side of this left half U is increasing. That upside down parabola is going uphill and then it goes downhill. Then it's constant. then it goes uphill, then it's constant again. So the first part, let's see what Caleb. Oh, Caleb, that is perfect. Because the first part is going from negative infinity, and then it has that peak at -6 on the x. So y'all let me see how we would write that. So I'm going parentheses, negative, you got an infinity down here, comma, what was that, Caleb? -6, and then close parentheses. Now do a comma, open parentheses again. This second part over here is going uphill. So you're going uphill, downhill, constant, and then you're increasing again. That real steep line, where does it start going uphill? Okay, let's see what you got. -1, good job. It starts at -1. And then where does it stop increasing? Well, y'all, that thing's right on the y-axis there. So that means x has to be 0 for that one. And then you would close those parentheses. So your increasing will have 2 intervals on this one, okay? So y'all, you would check that. Decreasing. Well, there's only one part decreasing, and that's the right side of that upside down parabola. Where does that start decreasing at? And where does it stop decreasing? On my x-axis. So -6 is where it started right there. So if you look at the peak and come straight down, -6, and then it looks like it stopped at, what do y'all got? -4. Whoops, y'all, if I don't put a comma in there, that's going to mark me wrong. So let me put my comma in there. And then close those parentheses. And y'all, that's the only part where I'm going downhill left to right. So constant, if you notice, there's 2 places where I got horizontal lines. So the first one down here, where does the first one start being constant and where does it stop being constant? So let's see, -4 here, and it looks like you're good, -4 to -1. All right, then we got to put a comma and start the next one. All right, so we got this one. How about this second one over here? Where does this one's where I get most of y'all at? Oh, Caleb, you done got it. Oh, God, good job. Most people put 6 to infinity, but they put 6 because they're looking at that y value again. Good job, y'all. That thing started on the x-axis at 0, and it's headed off towards positive infinity. So you would put that in there and then check that answer. All right, y'all, so I'm going to stop there. We're going to pick up with this stuff on Thursday night. We'll finish off this 6.8. There's a few more sections, and then we'll knock out 7.5. I just didn't want to overload y'all because there's a few things y'all had to learn tonight, and that was the radical domains. You had to graph the radicals. Then we got into doing the piecewise functions, and then finally the increase and decreasing. So y'all should be able to get through up to about number 7 in 6.8. And plus, remember, you had that little bit of support for 6.1. So do support 6.1, college algebra 6.1, and about half of 6.8. And then we'll finish off 6.8 and 7.5 on Thursday, okay? But y'all, they're not too bad. So let me see. Are y'all having any questions on this?